Hello there, and welcome to the Sleepy Science Channel. Tonight, we will be exploring the beautiful and mesmerizing world of fireworks, those brilliant bursts of light and color that paint the night sky with wonder. From ancient celebrations to modern displays, fireworks have captured human imagination for centuries. They are both art and science, tradition and spectacle, danger and beauty combined. If you enjoy these quiet explorations, I invite you to like and subscribe or share a simple thought down in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is rest, settle in, and allow the calm wonder of fireworks to carry you into peaceful dreams. Let's begin. The origins of fire and light. Fireworks began with a simple accident in ancient China. More than 1,000 years ago, somewhere in the mountains of China, an alchemist was mixing ingredients. Saltpeter, charcoal, and sulfur came together in proportions that had never been combined before. When heat touched this mixture, something extraordinary happened. Instead of simply burning, the compound exploded with a sharp crack and a brilliant flash. This was black powder, the first true explosive, and it would change human celebration forever. The Chinese called it fire medicine, and they quickly discovered that when packed into bamboo tubes, it could create spectacular effects. The bamboo would burst with a satisfying bang, scattering sparks in all directions. What began as an alchemical experiment became the foundation of something magical. Ancient cultures believed loud noises could ward off evil spirits. Long before fireworks became entertainment, they served a spiritual purpose. Across Asia, people believed that darkness harbored malevolent forces. Ghosts, demons, and spirits of misfortune were thought to linger at the edges of firelight, waiting to bring harm. The loud crack of bursting bamboo filled with black powder was believed to frighten these entities away. During festivals and important ceremonies, communities would light these primitive fireworks to cleanse the air of negative energy. The louder the explosion, the more effective the protection. This belief was so strong that fireworks became integral to celebrations marking new beginnings. Weddings, harvests, and the new year all called for fire and noise. What we see today as spectacle was once seen as spiritual defense. The earliest fireworks were simply bamboo tubes filled with gunpowder. Before metal casings and complex chemical mixtures, fireworks were remarkably simple. Craftsmen would take hollow sections of bamboo, those natural tubes that grew abundantly across Asia, and pack them carefully with black powder. One end would be sealed, the other left open or loosely capped. A fuse, often just a length of slower burning material, would be inserted. When lit, the powder would ignite and the pressure would build until the bamboo could no longer contain it. The result was a sharp explosion, a flash of light, and fragments of bamboo scattering like wooden shrapnel. The sound echoed across valleys and through streets, announcing celebration. These simple devices were the ancestors of every firework that has ever lit the sky since. Fireworks spread along the Silk Road to the Middle East and Europe. As traders carried goods across the vast network of routes connecting East and West, they also carried knowledge. Among the silk, spices, and precious metals traveled the secret of black powder. By the 13th century, the formula had reached the Middle East, where Arab chemists refined it and documented its properties. From there, it moved into Europe through trade and conquest. European alchemists and military engineers saw potential in this explosive powder. Initially, it was used for warfare, for cannons and siege weapons that could breach castle walls. But the spectacular nature of explosions did not go unnoticed. By the 14th century, Italian pyrotechnicians began experimenting with fireworks as entertainment. creating displays for wealthy patrons and religious festivals. What had begun in Chinese mountains was now illuminating European skies. Italian craftsmen became masters of the pyrotechnic art. In the city-states of Renaissance Italy, fireworks evolved from simple explosions into sophisticated spectacles. Florentine and Bolognese artisans competed to create the most impressive displays, developing new techniques for controlling color, shape, and timing. They discovered that different metal compounds produced different colors when burned. Strontium salts created reds, copper produced blues and greens, sodium gave yellows. These craftsmen guarded their secrets carefully, passing knowledge from master to apprentice in workshops where recipes were closely protected. Italian fireworks masters were hired by royal courts across Europe, bringing their art to celebrations of power and prestige. They built elaborate wooden frameworks shaped like castles, gardens, or mythological scenes, then festooned them with fireworks that would ignite in sequence, telling visual stories in light and fire. Royal celebrations demanded increasingly elaborate displays. Kings and queens understood the power of spectacle. A magnificent fireworks display demonstrated wealth, technological sophistication, and the ability to command rare skills and materials. Royal weddings, military victories, and coronations became occasions for ever more ambitious shows. Entire artificial landscapes would be constructed on riverbanks or palace grounds, rigged with thousands of individual fireworks. Some displays lasted for hours, beginning at dusk and continuing until dawn. Barges on the Thames in London would be loaded with fireworks for celebrations, creating reflections that doubled the spectacle. French kings commissioned displays so elaborate that teams of pyrotechnicians would work for months in preparation. Sketches and paintings from these eras show structures taller than buildings, fountains of sparks, and skies filled with artificial stars. The night sky became a canvas for royal power. The earliest colors were simply the orange and white of burning powder. For centuries, fireworks were limited in their palette. The basic chemical reaction of black powder burning produced bright white and orange-yellow light, along with showers of golden sparks. This was beautiful in its own right, the warm colors against darkness creating a primal sense of wonder. But pyrotechnicians dreamed of more. They wanted the full spectrum of colors, the ability to paint the sky in any hue. Early attempts involved adding various substances to the powder, with mixed results. Some materials produced color but were unstable or toxic. Others created only slight tints. The breakthrough came gradually through the 19th century, as chemistry became a more precise science. The discovery that specific metal salts produced specific colors when heated to high temperatures opened new possibilities. Suddenly, the night sky could bloom in reds, blues, greens, and purples. Adding metal salts created the vibrant colors we see today. The secret to colored fireworks lies in the behavior of electrons in metal atoms. When these atoms are heated intensely, their electrons absorb energy and jump to higher energy levels. As they fall back to their normal state, they release that energy as light of specific wavelengths. Different metals release different wavelengths, which our eyes perceive as different colors. Strontium carbonate and lithium salts produce crimson reds. Barium compounds create green. Copper produces blue, though this is one of the most difficult colors to achieve at the right intensity and purity. Sodium gives brilliant yellow-orange. By carefully selecting which metal compounds to include in the pyrotechnic mixture, craftsmen can control the color of each burst with precision. Modern fireworks often contain multiple compounds that burn in sequence, creating shells that change color as they expand. Each firework shell is a carefully engineered package. What seems like simple magic is actually meticulous design. A typical aerial firework shell consists of several components working together. At the center is the bursting charge, a small amount of explosive that will eventually tear the shell apart. Surrounding this are the stars, small compacted pellets of pyrotechnic composition that will become the points of light we see. These stars are arranged in specific patterns within the shell, determining the shape the firework will form when it bursts. The entire assembly is wrapped in a spherical or cylindrical casing, traditionally made of paper but sometimes plastic. A time delay fuse runs from the bottom, where the lifting charge is located, to the bursting charge at the center. When the shell is launched, both the lifting charge and the delay fuse are ignited. The shell shoots upward, and as it reaches the peak of its arc, the delay fuse reaches the bursting charge, exploding the shell and igniting all the stars simultaneously. The lifting charge propels fireworks hundreds of feet into the air. The journey of a firework begins with an explosion at ground level. Inside the mortar tube, a lifting charge of black powder sits beneath the shell. When this charge is ignited, it produces a massive amount of hot gas in a fraction of a second. This expanding gas has nowhere to go but up, and it propels the shell out of the tube at tremendous speed. The amount of lifting charge is carefully calculated based on the weight of the shell and the desired height. A small shell might rise 200 feet, while massive shells can climb over 1,000 feet into the air. As the shell ascends, it leaves a trail of sparks from the delay fuse burning, creating the familiar ascending comet trail. The shell slows as it fights against gravity, and at the precise moment it reaches its apex, the internal fuse reaches the bursting charge. This timing is critical for the proper effect. Time delay fuses ensure explosions happen at the perfect height. The artistry of fireworks depends entirely on timing. If a shell explodes too early, the effect is small and disappointing, lost in the lower sky. If it explodes too late, or not at all, it becomes a dangerous projectile falling back to Earth. The time delay fuse is a carefully measured length of material that burns at a known, consistent rate. Pyrotechnicians calculate the burning time based on the expected ascent time of the shell. For a shell that will take 5 seconds to reach 400 feet, the fuse must burn for exactly 5 seconds. Environmental factors like humidity and temperature can affect burn rates, so experienced technicians adjust their timing accordingly. Modern fireworks often use electronic ignition systems with precise digital timing, but the principle remains the same. The goal is always to have the shell burst at the moment it reaches the top of its trajectory, when it has slowed to a near stop, suspended for just an instant against the sky. Modern fireworks can reach heights of over 1,000 feet. The largest firework shells are enormous, some weighing hundreds of pounds and requiring heavy machinery to load into their mortars. When launched, these giants climb to impressive altitudes. Commercial displays regularly feature shells that burst at 800 to 1,000 feet above the ground. The largest shells ever created, built for special record-breaking attempts, have reached even higher. A shell that explodes at great height creates a larger visible effect, with more space for the stars to spread before burning out. The pattern appears bigger and can be seen from greater distances. However, launching shells to extreme heights requires very powerful lifting charges and strong mortars. Wind at high altitudes can also push the shell off course, causing it to drift away from the intended position. For this reason, most displays use a variety of shell sizes and heights, creating a layered effect at different levels of the sky. Some shells weigh hundreds of pounds and require teams to handle. The construction of large firework shells is a serious undertaking. These massive devices cannot be carried by a single person or easily positioned. Teams of pyrotechnicians work together to transport them from storage to the firing site. The shells must be handled carefully despite their robust construction, as any damage to the casing or internal components could cause a malfunction. Loading a heavy shell into its mortar requires coordination and often specialized equipment like hoists or cranes. Once in position, the shell is armed by connecting its fuse or ignition system to the firing control. Safety protocols are rigorous when working with large shells, as the amount of explosive material they contain is substantial. A premature detonation of a large shell at ground level would be catastrophic. Yet when launched successfully, these massive shells create the most memorable moments of any fireworks display. Their enormous bursts filling the entire visible sky with color and light. The science of color and light. Strontium creates the deep reds that bloom across the sky. Red is one of the most striking colors in a firework display, demanding attention with its warm, intense glow. This color comes from compounds containing strontium, a soft, silvery metal that burns with a brilliant crimson flame. Strontium carbonate and strontium nitrate are the most common compounds used. When heated to high temperatures by the burning pyrotechnic mixture, strontium atoms emit light at wavelengths around 600 to 700 nanometers, which our eyes perceive as red. The challenge with red fireworks is achieving sufficient brightness. Red light is at the lower energy end of the visible spectrum, so it naturally appears dimmer than blues or whites. Pyrotechnicians compensate by using generous amounts of strontium compounds and ensuring complete combustion. The result is those gorgeous ruby bursts that spread across the darkness like flowers of fire opening their petals. Barium compounds paint the night with brilliant greens. Green fireworks have an almost magical quality, their cool light seeming to float rather than burn. This effect comes from barium, another metallic element that produces a characteristic color when burned. Barium chlorate and barium nitrate are typically used in green pyrotechnic formulas. When properly combusted, barium emits light primarily at wavelengths around 500 to 550 nanometers, creating shades from yellow-green to a pure emerald. Green is one of the easier colors to produce brightly, which is why it is so common in firework displays. The light has good visibility, even against the glow of ambient light from cities. Mixing barium compounds with other ingredients allows pyrotechnicians to adjust the shade, creating everything from pale lime to deep forest green. When a green shell bursts overhead, it brings to mind growing things, renewal, and the tranquility of nature. Copper chloride produces the difficult but stunning blues. Blue is the most challenging color to create in fireworks, and the most prized when done well. The difficulty comes from the chemistry of copper compounds, which produce blue light but require very specific conditions to do so effectively. Copper chloride is the primary source of blue color, emitting light at wavelengths around 450 nanometers when burned at the right temperature. The problem is that copper compounds need high temperatures to emit their blue light, but too much heat or the presence of certain other chemicals can shift the color toward green or white. Creating pure, bright blue requires carefully balanced formulas and precise control of the burning process. Despite these challenges, when a true blue shell bursts against the darkness, the effect is breathtaking. The color has a coolness and depth that contrasts beautifully with the warm oranges and reds of other fireworks. Sodium creates bright yellow and golden tones. The sunny warmth of yellow fireworks comes from sodium, one of the most reactive elements. Sodium compounds like sodium nitrate or simple table salt, sodium chloride, burn with an intensely bright yellow-orange light. This light is so intense and pure that it is actually used in street lamps in some places because of its efficiency. In fireworks, Sodium emits light primarily at wavelengths around 590 nanometers, creating colors from golden yellow to orange, depending on the specific compounds used and the burning conditions. Yellow fireworks are among the brightest and most visible, their warm glow cutting through haze and competing ambient light. They create a sense of joy and celebration, reminiscent of sunlight. When combined with other colors in a multi-effect shell, yellow provides excellent contrast and highlights, making other colors appear even more vivid by comparison. Calcium produces orange, adding warmth to displays. Orange is a welcoming color, full of energy and warmth, and in fireworks, it often comes from calcium compounds. Calcium chloride and calcium sulfate burn with orange to red-orange light, emitting wavelengths around 620 nanometers. The color sits between the deep reds of strontium and the bright yellows of sodium, creating a sunset glow that feels both energetic and comfortable. Orange is also naturally produced by burning charcoal, one of the basic components of black powder, so many fireworks have orange elements, even when other colors are intended. This happy accident adds depth and warmth to displays. Pure bright orange requires careful formulation to avoid drifting too far into red or yellow. When achieved, orange shells create bursts that resemble autumn leaves or glowing embers scattered across the night, warm and inviting. White light comes from burning aluminum or magnesium. The brightest, most intense light in fireworks is white, and it comes from burning metals that produce heat so intense it emits light across the entire visible spectrum. Aluminum powder is commonly used, burning at extremely high temperatures and creating brilliant white light along with showers of silver sparks. Magnesium produces an even brighter white light, though it is more reactive and must be handled carefully. Titanium is sometimes used for white sparks that persist longer as they fall. White fireworks serve multiple purposes in displays. They provide brilliance and contrast, making colored effects nearby appear more saturated. They create visual punctuation, bright flashes that emphasize key moments, and their sparking, twinkling quality adds texture and movement. The white trails left by ascending shells come from these same metals. Against the darkness, white fireworks seem almost impossibly bright, their light sharp and clean. Purple requires a careful mixture of strontium and copper. Purple is perhaps the most sophisticated color in a pyrotechnician's palette, and the most difficult to master. True purple cannot be created by a single element. Instead, it requires blending the red light from strontium with the blue light from copper. This is challenging because these elements have different ideal burning temperatures and conditions. If the balance is wrong, the result is pink or violet rather than true purple, or the colors may separate, creating a red and blue effect rather than a unified purple. Success requires precise ratios of compounds and carefully chosen fuel and oxidizer combinations that allow both strontium and copper to burn efficiently at the same time. Modern pyrotechnicians have largely solved these challenges, and purple fireworks are now more common and more vivid than ever before. When a purple shell bursts, it has a rich, regal quality, the color of twilight and royal robes. Pink fireworks blend white light with red compounds. Pink is a lighter, softer color than the deep reds of pure strontium, and creating it requires a different approach. The technique is to combine strontium compounds with materials that produce white light, typically aluminum or magnesium. The white light dilutes the intensity of the red, creating various shades of pink depending on the ratio. More white creates pale, almost peachy pinks, while more red creates hot magenta tones. Pink fireworks have grown more popular in recent years, valued for their gentle, romantic appearance. They create a different mood than intense reds, softer and more playful. In a display that features many bold, saturated colors, pink provides visual relief, a moment of delicacy. The technical challenge is maintaining consistent color, as small variations in how the components burn can shift pink toward white or red. When executed well, pink shells create bursts that look like spring blossoms scattered across the night. Charcoal creates the warm golden sparks, called fireflies. Among the most beloved effects in fireworks are the long-lasting golden sparks that drift slowly down after a burst. These glowing points, often called fireflies, derive their light from particles of charcoal. When charcoal is heated to incandescence, it glows with a warm orange-gold color. In firework stars, small pieces of charcoal or charcoal dust are included in the mixture. As the star burns, it heats these carbon particles, causing them to glow brightly. Because charcoal particles have mass and burn slowly, they persist long after the initial burst, falling gently under gravity while still glowing. This creates the illusion of living fireflies or embers drifting on the wind. Some formulas include metals along with charcoal to create sparks that are brighter or different colors, but the classic warm gold remains the most popular. These trailing sparks add life and movement to static bursts, their gentle descent contrasting with the violence of the explosion. Different burning temperatures produce different colors from the same metals. Chemistry gives pyrotechnicians fine control over color, but it also presents challenges. The color a metal produces depends not only on which metal it is, but also on how hot it burns. Copper, for example, can produce blue, green, or even whitish light, depending on temperature and the presence of other elements. This means that the surrounding formula matters as much as the colorant itself. Oxidizers, fuels, binders, and other components all affect combustion temperature and atmosphere. A formula that burns too cool might not excite the metal atoms enough to produce visible colored light. A formula that burns too hot might produce light that is too white or might cause the color to shift. Pyrotechnicians must balance all these factors, creating mixtures that burn at exactly the right temperature and rate to produce the desired effect. It is part science, part art, part experience. The chemistry of fireworks has been refined over generations. The formulas used in modern fireworks are the result of centuries of experimentation and gradual improvement. Early pyrotechnicians worked through trial and error, mixing compounds and testing them to see what happened. Successes were recorded and shared, while failures were learned from. Over time, certain combinations proved reliable and became standard. In the 20th century, as chemistry became more sophisticated, pyrotechnicians gained deeper understanding of why certain mixtures worked. They could predict behavior and design formulas for specific effects without as much guesswork. Today, computer modeling helps optimize formulas before they are ever physically tested. Yet the craft still relies heavily on traditional knowledge passed from master to apprentice. Some of the best firework formulas are still closely guarded secrets, small variations in ingredients or proportions that give a particular manufacturer or craftsman a distinctive look to their work. Modern formulas use precise measurements down to fractions of a gram. Creating fireworks today is an exercise in precision. Unlike the rough mixing of centuries past, contemporary pyrotechnicians weigh out ingredients carefully, often to within 1/10 of a gram or less. This precision ensures consistent results. A formula that has been tested and proven can be reproduced exactly, creating shells that behave identically every time they are fired. This is especially important for choreographed displays, where timing and effect must be predictable. Small variations in composition can lead to significant changes in performance. Too much oxidizer, and the star burns too fast, not lasting long enough, too little, and it may not ignite properly. The color-producing compounds must be present in sufficient quantity, but not so much that they affect the burn rate or produce unwanted byproducts. Digital scales, standardized measuring techniques, and careful record-keeping are essential tools in the modern pyrotechnician's workshop. Shapes and patterns in the sky. Round shells create spherical bursts called peonies. The most classic firework effect is the simple round burst called a peony. When this type of shell explodes, the stars are thrown outward in all directions equally, creating a sphere of light that expands from a central point. Peonies can be small and dense, or large and sparse, depending on the number of stars and the strength of the bursting charge. The beauty of a peony lies in its symmetry and completeness, the way it fills space uniformly. Different colors can be loaded to create solid color peonies, or mixed colors can be used for a confetti-like effect. The stars burn as they travel outward, leaving trails of light that fade before the stars burn out. In that brief moment, a perfect sphere of colored light exists in the sky, then vanishes, leaving only memory and perhaps traces of smoke drifting on the wind. Chrysanthemum shells burst with long, glowing trails. A chrysanthemum is a more elaborate version of a peony, distinguished by the trails left by the stars. In a chrysanthemum shell, the stars contain compounds that burn for a longer duration, typically charcoal or metal compositions that create long-lasting golden or silver sparks. When the shell bursts, each star traces a path through the sky, creating a flower-like effect with petals of light radiating from the center. The trails curve gracefully due to the combination of the star's outward velocity and the effects of gravity and air resistance. Chrysanthemums are often large and luxurious, taking several seconds to fully develop and fade. They have an elegant, graceful quality that makes them favorites for special moments in displays. The name comes from the resemblance to the flower, with its many thin petals. Like the flower, the firework version blooms briefly, then is gone. Willow shells cascade downward like a tree's branches. Where peonies and chrysanthemums spread outward, willow effects fall downward, creating an entirely different visual experience. Willow shells contain stars that burn for an extended time and are designed to produce long tails of sparks as they fall. When the shell bursts, the stars are thrown upward and outward, but they quickly succumb to gravity, arcing over and falling in long trails. The effect resembles the drooping branches of a willow tree, hence the name. The trails are usually golden or silver, created by burning charcoal or titanium compounds. A large willow shell can create an effect that seems to rain light, with dozens of bright streams cascading from a central point high in the sky. The downward motion is mesmerizing, creating a sense of softness despite the violent energies involved. Willows are often used later in displays when a gentler, more contemplative moment is desired. Palm tree effects spread upward, then fountain downward. Palm tree shells, also called coconut shells, create one of the most distinctive patterns in pyrotechnics. The effect is created using stars that produce very long-lasting, bright tails. When the shell bursts, the stars travel upward at high speed before falling back down, creating trajectories that curve up, then down, in long arcs. The result looks remarkably like the fronds of a palm tree spreading upward from the trunk. Palm effects are usually golden or silver, though colored versions exist. The key is the duration and brightness of the tails, which must persist long enough for the full arc of motion to be visible. Large palm shells are dramatic, their light lasting 5 seconds or more as the stars climb and descend. The effect has a tropical, exotic feel and adds vertical structure to a display. Multiple palm shells fired in sequence can create the illusion of a grove of trees made of light. Ring shells burst into expanding circles of light. One of the most satisfying geometric effects is the ring, a perfectly circular band of light that expands outward in a flat plane. Creating a ring requires precise construction. The stars must be arranged in a circle within the shell, all at the same distance from the center. When the shell bursts, all stars must receive equal force in the plane of the ring, while receiving minimal force perpendicular to that plane. This is achieved through careful placement of the bursting charge and sometimes the use of internal structures that guide the stars. When successful, the result is a crisp, clean ring of color that grows larger as it spreads, maintaining its circular shape. Rings can be combined with other effects, such as a peony inside a ring or multiple concentric rings of different colors. The precision required makes rings more challenging to produce than simple bursts, but the visual clarity of a perfect ring is worth the effort. Saturn shells create rings with a dense core at the center. Named after the ringed planet, Saturn shells combine two effects into one. At the center is a dense burst of stars creating a bright core, while surrounding it is a flat ring that expands outward. The effect mimics the appearance of the planet Saturn with its prominent rings. This is achieved by loading the shell with two separate groups of stars, one tightly packed at the center and another arranged in a ring at a specific radius. The bursting charge must be designed to give the ring stars outward velocity in a plane, while the central stars receive force in all directions. Timing is also crucial, as both effects should be visible simultaneously for maximum impact. Saturn shells are technically sophisticated and visually striking. Their combination of central explosion and geometric ring, creating a focal point that draws the eye. They are particularly effective as standalone centerpiece effects in a display. Crossette shells split into multiple smaller bursts. Rather than a single burst, crossette shells create multiple generations of effects. The shell bursts to release a small number of large stars, perhaps 4 or 8. These stars travel outward from the center, but they do not simply burn out. Instead, each star is actually a small self-contained firework. After traveling some distance, each star explodes, throwing out its own group of smaller stars in different directions. The result is a pattern that spreads, pauses, then suddenly multiplies. A 4-break crossette might create 4 initial streaks of light, then 16 smaller bursts as each breaks again. Some crossettes have 3 or even 4 generations, each breaking into more pieces. The effect is energetic and surprising, creating a sense of ongoing activity rather than a single moment. Crossettes add complexity and depth to displays, their serial explosions extending the duration and filling more space with light. The technical challenge is timing all the breaks correctly and ensuring they occur at altitudes where they remain visible and safe. More patterns and effects. Horsetail effects create dense showers of sparks. The horsetail is a variation on the willow, but denser and more intense. Where a willow has distinct trails, a horsetail packs many more spark, producing stars into the shell, creating a thick curtain of falling light. When a horsetail shell bursts, hundreds or thousands of tiny sparks are released simultaneously, spreading outward and upward before falling in a cascade. The effect resembles a horse's tail swishing, hence the name, or water from a fountain arcing up then falling back. Horsetails are usually golden or silver, the warm glow of burning titanium or charcoal compounds, creating a rich, luxurious appearance. The density of sparks creates an almost solid-looking mass of light that slowly descends and disperses. Large horsetail shells are among the most spectacular effects in pyrotechnics, their sheer volume of light creating moments of brilliance that illuminate the ground below. Kamuro shells drop dense golden tentacles from the burst point. The kamuro is a Japanese effect, the name meaning boy's haircut, referring to a traditional hairstyle with dense, straight hair falling from the crown. Kamuro shells burst to release an enormous number of thick, bright tails that fall almost straight down from the point of explosion. Unlike willows, which spread outward, Kamuro stars travel primarily downward, creating the appearance of a golden jellyfish or an inverted fountain. The stars produce very bright, long-lasting sparks, usually golden or silver. The effect is heavy and imposing, a serious curtain of light that commands attention. Large Kamuro shells are expensive and complex to build due to the number of stars required and the precision needed to make them all fall together in a tight group. When executed properly, the result is one of the most impressive effects in fireworks, a waterfall of light pouring from the sky. Brocade effects create a soft, glittering texture in bursts. Brocade is a subtle effect that adds texture and complexity to firework bursts. The name comes from the woven fabric that features elaborate patterns and rich texture. In fireworks, brocade refers to stars that produce small, delayed secondary bursts as they travel, creating a crackling or glittering effect. Each star might crackle 10 or 20 times as it burns, each crackle producing a small flash and a sharp sound. When hundreds of these stars spread outward from a burst, the combined effect is a shimmering, alive quality, as if the burst is breathing or twinkling. Brocade can be combined with other effects, adding texture to peonies or chrysanthemums. The sound component is as important as the visual, the rapid fire popping, adding an auditory dimension that enhances the experience. Brocade creates a sense of richness and luxury, turning a simple burst into something more elaborate and engaging. Strobe effects flash on and off as stars travel through the sky. One of the most modern and eye-catching effects is the strobe, where stars flash brightly on and off in rapid succession as they move. This is achieved through specialized chemical formulations that burn in pulses rather than continuously. Metals like magnesium, combined with specific oxidizers, create reactions that are self-interrupting, burning intensely for a fraction of a second, then pausing, then burning again. The result is stars that appear to blink or pulse as they travel, creating a disorienting, attention-grabbing effect. Strobe shells might contain stars that all pulse in unison or that pulse at random, creating a chaotic flickering pattern. The effect is modern, almost electronic in appearance, contrasting with the organic flow of traditional effects. Strobe shells are popular in contemporary displays, their energetic pulsing matching the rhythm of music in choreographed shows. They add a sense of urgency and excitement that other effects cannot match. Glitter creates tiny star-like sparkles that shimmer as they fall. Glitter is one of the most delicate and beautiful effects in the pyrotechnician's repertoire. Unlike the long trails of charcoal streamers, glitter creates tiny points of light that flicker on briefly, then fade, resembling stars twinkling in the night sky. The effect is created using formulas that produce small, bright flashes at irregular intervals. The composition typically includes aluminum or magnesium, along with other ingredients that create brief, intense combustion events. When a glitter shell bursts, the stars spread outward trailing clouds of these tiny flashing particles. The visual effect is ethereal and magical, as if the burst is scattering actual stardust. Glitter can be added to other effects to enhance them, or used alone for a pure, shimmering appearance. It is particularly effective in dark skies where the individual glitter flashes can be seen clearly. each one a tiny spark of light that exists for just a moment before vanishing. Spider effects spread thin filaments of light. The spider is an effect characterized by fine, delicate threads of light radiating from a central burst. Unlike the thick trails of a chrysanthemum or the dense cascade of a horsetail, spider effects produce thin streams that travel fast and far. The stars in a spider shell are small and burn relatively quickly, producing bright but narrow trails. When the shell bursts, these stars shoot outward at high velocity, their thin trails creating the appearance of a spider's legs reaching out in all directions. The effect is fast and energetic, the opposite of the gentle, slow-falling willow. Spiders are often used to inject energy into a display, their quick motion and sharp lines providing contrast to softer effects. They can be colored or white and are particularly effective when fired in groups, creating multiple spiders that overlap and interweave in the sky. Heart-shaped shells require precise internal arrangement of stars. Among the most technically challenging effects are shapes, and hearts are one of the most popular. Creating a heart requires positioning the stars within the shell in the exact pattern desired. The stars are glued or otherwise fixed to a framework that holds them in place. When the shell bursts, the stars separate from the framework but maintain their relative positions briefly, creating the outline of a heart shape. The challenge is that the stars are traveling at high speed and subject to air resistance and gravity, which can distort the shape. Success requires careful calculation of how the pattern will evolve from the moment of burst through the several seconds it remains visible. The stars must burn long enough for the shape to be recognized, but not so long that it becomes unrecognizable as they spread. Heart shells are expensive and complex, but they create memorable moments in displays, especially at weddings or Valentine's Day celebrations. Smiley face shells bring whimsy to the night sky. Even more whimsical than hearts are smiley face shells, which create the iconic simple face with 2 dots for eyes and a curved line for a smile. These shells require even more precise construction than hearts, as the pattern has distinct separate elements that must maintain their relationships. The eyes are typically created by 2 small groups of stars, while the smile is formed by an arc of stars. Everything must be positioned just right within the shell and must burst with the correct force to spread the elements to the right distances. The bursting charge must be carefully shaped to avoid giving any part of the pattern unwanted momentum. When successful, the appearance of a giant smiling face in the sky is delightful and unexpected, bringing laughter and joy to spectators. These shells are often used in family-friendly displays or at moments designed to lift spirits and create a sense of playfulness. Letters and numbers can be spelled out in fire. The ultimate expression of control in fireworks is the ability to spell out letters and numbers. Each character must be formed by stars positioned in the right pattern, and multiple shells might be fired in sequence to spell out words. The technical challenges are immense. Each letter requires a custom-loaded shell with stars placed in precise positions. The letters must be oriented correctly so they appear right way up to viewers on the ground, which means calculating the shell's rotation and trajectory. The size of the letters must be appropriate for the viewing distance, large enough to be read, but not so large that they are distorted before burning out. Despite these difficulties, letter shells are increasingly common, used to spell out names, short messages, or dates. They represent the pinnacle of shaped shell technology, where art, engineering, and chemistry combine to write messages in the sky. Multiple breaks create shells within shells for extended effects. Some shells are designed to burst more than once, creating layered effects that unfold over several seconds. A double break shell might burst first to release a ring of colored stars, then a fraction of a second later burst again to send out a second ring of a different color. Triple break shells add a third layer, and some shells have 4 or even 5 breaks. Each break requires its own bursting charge and time delay, all carefully synchronized. The visual effect is dramatic, as the burst seems to bloom in stages, each layer adding new color or pattern. Multiple break shells are larger and more expensive than single break shells, but they create focal point moments that justify the cost. Watching a shell burst, then burst again, then continue to evolve, creates anticipation and satisfaction. A small story told in light over the span of a few seconds. The sounds of celebration. Small firecrackers produce sharp, quick pops. Not all fireworks are about visual spectacle. Sound plays an equally important role in celebration. The simplest sound producing fireworks are small firecrackers, tiny tubes of paper wrapped tightly around a small charge of flash powder. When ignited, the powder burns instantly, creating gas that ruptures the paper casing with a sharp pop. Individual firecrackers are small, but they are often bundled into strings containing hundreds or thousands. When lit, the string creates a rapid-fire series of pops that can last for minutes. The sound is energetic and chaotic, impossible to ignore. In many cultures, strings of firecrackers are an essential part of celebration, hung from doorways or trees, and lit to announce joy and ward off evil. The smell of burnt paper and gunpowder, combined with the relentless popping, creates a sensory experience that is visceral and immediate. Salutes create loud single bangs that echo for miles. For maximum volume, nothing matches a salute. These devices are designed specifically to produce noise rather than visual effects. A salute consists of a strong casing packed with flash powder, a mixture that burns extremely rapidly, producing a tremendous amount of gas almost instantaneously. The pressure ruptures the casing with a deafening bang. Large salutes can be heard for miles and are felt as much as heard. The shockwave, creating a physical pressure on the chest. Salutes are used in displays to punctuate key moments, to wake up inattentive crowds, or to create dramatic emphasis. Multiple salutes fired simultaneously create overlapping shockwaves that can be overwhelming. While they lack visual interest, their power is undeniable. The bang of a large salute is primal, triggering deep responses in the brain that signal importance and demand attention. Flash powder creates the loudest explosions in fireworks. The key to loud fireworks is flash powder, a mixture quite different from traditional black powder. Flash powder typically consists of a metal fuel, usually aluminum or magnesium, mixed with a powerful oxidizer like potassium perchlorate. When ignited, this mixture deflagrates, meaning it burns extremely rapidly but does not quite detonate. The burn is so fast, however, that it generates gas at an incredible rate, creating a sudden, massive increase in pressure. This is what produces the loud bang and bright flash. Flash powder is significantly more powerful than black powder and must be handled with great care. Even small amounts can produce loud reports, while larger quantities create bangs powerful enough to damage hearing if experienced at close range. For this reason, salutes and other flash powder devices are heavily regulated in terms of size and composition for consumer use. Whistles create rising or falling tones as they burn. Among the more musical fireworks are whistles, which produce a distinctive rising or falling tone as they operate. A whistle is a tube containing a specially formulated composition that burns in a particular way. As the composition burns, it creates pressure oscillations within the tube, similar to how a musical instrument creates sound. The pitch of the whistle depends on the size and shape of the tube and the burn rate of the composition. Some whistles rise in pitch as they burn, while others fall. The sound is eerie and attention-getting, quite different from the bangs and cracks of other fireworks. Whistles are often incorporated into aerial shells, adding an auditory component to the visual burst. A shell that whistles on the way up creates anticipation, announcing its arrival before the burst. The sound is unmistakable and adds another dimension to the fireworks experience. Crackling effects produce rapid series of small pops. Crackling compositions, sometimes called dragon eggs, create a machine gun-like series of small explosions. These effects use formulations similar to those in brocade fireworks, but more intense. The composition is made into small pellets or granules, which are then spread among the stars in a shell or included as part of the star composition itself. As these pellets burn and explode, each creates a small pop and flash. When hundreds or thousands of pellets are involved, the result is a sustained crackling sound that lasts for several seconds. The auditory experience is satisfying, a rapid-fire series of reports that keeps the ear engaged long after the initial visual burst has faded. Crackling adds texture and depth to effects, turning a simple peony into a more complex sensory experience. It also helps maintain interest during moments when there might otherwise be a lull in the display. Thundershells combine deep booms with rumbling echoes. Some fireworks are designed to produce sound that has depth and resonance rather than sharp cracks. Thundershells use large quantities of flash powder and sometimes specialized compositions to create deep, booming sounds that echo and roll. The effect is meant to mimic thunder, hence the name. Unlike the sharp, instantaneous bang of a salute, a thundershell's report has duration. The sound rolling out across the landscape and reflecting off buildings or hills. Multiple thundershells fired in sequence can create an artificial thunderstorm, a dramatic auditory landscape that adds atmosphere to a display. The physical sensation of a deep boom is different from a sharp crack, affecting the body in a more visceral, whole-body way. Thundershells are particularly effective in large outdoor venues, where the sound has room to expand and echo, creating an immersive experience. Howling effects create sustained screaming sounds. Perhaps the most unsettling sounds in fireworks come from howlers or screamers, devices that produce sustained, high-pitched tones or wavering wails as they burn. These effects use compositions and tube designs that create continuous pressure oscillations, similar to whistles but more chaotic and less musical. The resulting sound can be quite loud and piercing, cutting through other noise to demand attention. Howlers are used sparingly in most displays because their sound can be unpleasant if overused, but they are effective for creating a sense of energy or frenzy. They are particularly popular in certain cultural celebrations where the goal is maximum noise and activity. The sound is memorable and distinctive, often continuing for several seconds as the device burns through its charge. When combined with visual effects, howlers add an element of urgency and intensity that pure bangs cannot match. Multiple simultaneous explosions create a physical shockwave. When many salutes or other loud fireworks are fired at precisely the same moment, the combined effect is more than additive. The overlapping shockwaves combine, creating a pulse of pressure that can be felt viscerally by spectators. This technique is used to create punctuation points in displays, moments where both eyes and body are overwhelmed by the intensity. A well-timed volley of salutes can create a boom that makes clothing flap, that is felt in the chest as if the heart skipped a beat. It is dramatic and unforgettable, a demonstration of raw power. The technique requires precise timing, as shells that fire even fractions of a second apart create a roll of individual booms rather than a single unified shockwave. Electronic firing systems make this precision possible, allowing pyrotechnicians to synchronize dozens or hundreds of shells with perfect timing. The finale typically includes the loudest sounds of the display. Every fireworks display builds toward its conclusion, and the finale is where everything intensifies. More shells are fired in the finale than at any other point, and among them are the largest and loudest. Rapid-fire sequences of salutes create sustained thunder. Walls of ascending shells whistle and scream on their way up. The bursts come so fast they overlap. Multiple explosions happening simultaneously. The sound becomes nearly continuous, a roar that overpowers conversation and thought. Combined with the visual intensity of hundreds of bursts filling the sky at once, the auditory assault creates sensory overload in the best possible way. For those final moments, the world contracts to just the display, all attention pulled upward to the sky that has become a storm of light and sound. Then it ends, suddenly, and the silence that follows is profound. The art of display design. Professional displays are carefully choreographed for maximum impact. Creating a fireworks display is not simply loading shells and firing them. It is an art form that requires planning, creativity, and technical skill. Professional pyrotechnicians spend hours or days designing a show, selecting which effects to use, in what order, and with what timing. The goal is to create an emotional journey for the audience, building excitement, varying pace and intensity, creating moments of surprise and moments of calm. A good display has structure, with a beginning that establishes themes, a middle that develops them, and a finale that brings everything to a climax. Each effect is chosen for a reason, to create a specific feeling or to set up the next moment. Colors are selected to work together or to contrast. Heights are varied to use different parts of the sky. The result is a performance that feels cohesive and intentional rather than random. Displays begin quietly, building energy gradually. The opening of a fireworks display sets the tone and expectation. Most shows begin with smaller, quieter effects, giving the audience time to settle in and adjust to the experience. Early shells might be medium-sized peonies and chrysanthemums, pretty but not overwhelming. The pace is measured, with moments of pause between shells to let each one be appreciated. This gentle beginning serves multiple purposes. It gives late arrivals time to find their places. It establishes that something special is happening without exhausting the audience immediately. And it creates a baseline against which later, larger effects will seem even more impressive. The gradual build in energy and intensity is fundamental to good display design, creating an arc that carries the audience along rather than hitting them with everything at once. Color schemes are planned to create visual harmony. Just as a painter selects a palette before beginning work, pyrotechnicians plan the colors they will use throughout a display. Some shows use a wide variety of colors, creating a rainbow effect. Others focus on a limited palette for a more unified aesthetic. National colors might be featured for patriotic holidays, red, white, and blue in America, or red and white in Canada, or other combinations elsewhere. Color transitions can tell a story, beginning with cool blues and greens, and warming toward reds and golds, or vice versa. Complementary colors are often paired for maximum visual impact. Blue and orange, red and green, purple and yellow. The sequence of colors affects the mood, with warm colors feeling energetic and cool colors feeling calm. Careful color planning elevates a display from a random collection of shells into a coherent visual experience. Timing and rhythm create the music of fireworks. Even without accompanying music, a good fireworks display has rhythm. The timing between shells creates a sense of pace. Rapid fire sequences feel exciting and intense. Longer pauses create anticipation, and allow effects to be appreciated individually. Alternating between fast and slow sections creates variety and prevents monotony. Some sequences fire shells in groups, creating accents like drum beats. Others stagger shells slightly so bursts overlap, creating a cascading effect. Professional pyrotechnicians think in terms of measures and phrases, borrowing concepts from music. A sequence might build over 8 shells, then release with a larger burst, creating a pattern that feels resolved. These subtle rhythmic choices affect how the display is experienced, even if spectators are not consciously aware of them. A well-timed show feels satisfying and complete, while poor timing creates confusion or boredom. Low-level effects add depth and variety to the show. Not all fireworks shoot hundreds of feet into the air. Ground-level and low-altitude effects are essential components of a complete display. Fountains spray sparks upward from fixed positions, creating pillars or fans of light. Wheels spin rapidly, creating circles or spirals of fire. Comets shoot horizontally across the ground or rise in low arcs. These effects serve multiple purposes. They fill the lower portions of the viewing area, creating a layered landscape of light at different heights. They provide activity during moments when no aerial shells are bursting, and they create variety in the types of effects shown, preventing the display from becoming monotonous. Low effects are often used during the opening, or to separate major sections of a show, or as part of finales where every available space is filled with light and motion. Cake fireworks create rapid sequences from a single device. A fireworks cake, also called a multiple tube device, is a box containing many small mortar tubes side by side, each loaded with a shell. When ignited, the cake fires its shells in rapid sequence or in patterns, creating a self-contained mini display. Cakes are popular in professional shows because they simplify setup, one large cake replacing dozens of individual shells. They are also common in consumer fireworks because they allow people with limited technical knowledge to create impressive effects safely. Modern cakes can contain dozens or even hundreds of tubes, firing for a minute or more. Some cakes are designed to fire all tubes in a rapid finale burst. Others create patterns, firing shells from different positions to spell out shapes or create sweeping motions across the sky. The innovation in cake design has been significant in recent years, with ever larger and more complex devices available. Finales pack the sky with as many shells as possible. The finale is the climax toward which the entire display has been building. For these final 30 seconds to 2 minutes, shells are fired as rapidly as the equipment and safety allows. Dozens or hundreds of shells might be in the air simultaneously, their bursts overlapping to create a nearly solid wall of light and color. The goal is sensory overload, to create an experience so intense that it becomes memorable. Every mortar is used, firing everything remaining in the inventory. Salutes thunder continuously. The air fills with smoke that catches and reflects the light, adding to the chaos. Colors mix and blend. Effects layer over effects. The sound is deafening. The light is overwhelming. Spectators often cheer or gasp involuntarily, unable to process the sheer volume of stimulation. Then, suddenly, it is over. The last echoes fading, the last sparks drifting down, and the night returns. The silence after a finale feels profound and heavy. After the finale's roar, the quiet that descends feels almost physical. Ears ring from the prolonged noise. Eyes adjust slowly back to the darkness. The smell of smoke hangs in the air, drifting across the crowd. For a few moments, no one speaks, everyone processing what they have just experienced. Then the applause begins, or cheers, or simply conversation resuming. That moment of silence, though, is important. It is the space where the experience settles, where memory is formed. A good display creates a sense of completion, a feeling that something significant has been witnessed. The silence allows that significance to be felt before the mundane world reasserts itself, and people begin gathering their belongings and heading home, carrying the memory of what they saw written in light across the darkness. Fireworks around the world. Chinese New Year features some of the largest displays on Earth. In China, the birthplace of fireworks, celebrations during the New Year are spectacular beyond description. Entire cities participate, with fireworks launched from buildings, bridges, and public squares. The displays can last for hours, sometimes running continuously through the night. The amount of fireworks used is staggering, measured not in shells but in tons. Major cities compete to create the most impressive shows, employing hundreds of pyrotechnicians and using the latest technologies. The displays often incorporate themes from Chinese mythology or the zodiac animal of the coming year. Dragons and phoenixes might be spelled out in fire. Massive cascades of golden sparks fall from tall buildings. The sky becomes a canvas for cultural expression on an enormous scale. For those who witness these displays in person, the experience is overwhelming, a demonstration of both technical prowess and cultural pride. India's Diwali celebrations light millions of small lamps and fireworks. Diwali, the festival of lights, is one of India's most important celebrations, and fireworks are central to the observance. Unlike the concentrated displays of Western shows, Diwali fireworks are distributed across entire communities. Families and neighborhoods set off their own fireworks throughout the evening and into the night. The result is a citywide celebration where fireworks bloom constantly from all directions. Sparklers are particularly popular, held by children who trace patterns in the air. Flower pots, small fountains that spray colorful sparks, sit on doorsteps and balconies. Aerial shells burst overhead, but the real magic is in the aggregate effect. Thousands of individual celebrations combining into a landscape of light. The festival celebrates the victory of light over darkness, and the proliferation of small lights everywhere embodies this theme perfectly. American 4th of July displays celebrate independence with patriotic colors. In the United States, Independence Day is the major occasion for fireworks, and displays across the country share common themes. Red, white, and blue dominate the color schemes, reflecting the national flag. Displays often accompany patriotic music, with shells timed to songs like the Star-Spangled Banner or the Battle Hymn of the Republic. Major cities host large public displays, while smaller towns create more modest shows. Communities gather in parks, on beaches, or anywhere with a view of the sky. The tradition dates back to the earliest independence celebrations in the late 1700s, when fireworks were already associated with important events. Today, American displays are known for their scale and the integration of music, creating multimedia experiences that blend sight, sound, and patriotic feeling into a cohesive whole. Japan's firework festivals are artistic competitions between craftsmen. In Japan, fireworks, or hanabi, meaning flower fire, are treated as a serious art form. Summer festivals feature displays that are judged and awarded prizes, with pyrotechnicians competing to showcase their skills and innovations. Japanese fireworks often emphasize beauty and subtlety over sheer size or volume. Effects like kamaro and bees, or warimono, blooming flowers, are executed with precision and attention to aesthetic balance. The displays are accompanied by traditional music and often incorporated into broader cultural festivals. Spectators dress in summer yukata and watch from riverbanks or designated viewing areas. The appreciation is deep and knowledgeable, with audiences recognizing and applauding particularly skillful or innovative shells. This cultural approach has pushed Japanese pyrotechnic art to high levels, and Japanese craftsmen are renowned worldwide for the quality and artistry of their work. European displays often feature fireworks set to classical music. In Europe, firework displays frequently accompany orchestral music, creating a synthesis of auditory and visual art. Cities like Edinburgh during its Hogmanay celebration, or London for various national events, create shows where shells burst in time with musical crescendos and movements. The choreography is precise, with specific effects chosen to match the mood and tempo of the music. A slow, romantic passage might feature gentle willows and soft colors, while a triumphant finale of a symphony is accompanied by massive bursts and thunderous salutes. These shows require extensive planning and technical expertise, as timing must be exact. The use of classical music adds a layer of cultural sophistication and appeals to audiences who might not otherwise be interested in fireworks. The combination elevates both arts, each enhancing the other. Australia's New Year celebrations are among the first worldwide. Due to its geographic location, Australia enters the new year before most of the world, and its celebrations, particularly in Sydney, are broadcast globally. The Sydney Harbour fireworks display is iconic, using the harbour bridge and surrounding landmarks as part of the show. Shells burst above the water, their reflections doubling the visual impact. The display is meticulously planned and executed, serving as a preview of celebrations to come in other time zones. The warm summer weather allows for outdoor gatherings, and hundreds of thousands of people line the harbour foreshore to watch. The display incorporates Australian themes and often features indigenous elements. Its timing and location make it one of the most watched fireworks displays in the world, a spectacular beginning to the global New Year celebrations. Traditional celebrations often include fire dancing and lantern releases. Fireworks exist within a broader cultural context of fire-based celebrations. In many cultures, fire dancing, where performers spin or manipulate burning materials, accompanies firework displays. Sky lanterns, paper balloons, lifted by the heat of small fires, are released in mass launches that create floating fields of light drifting upward. These traditions connect to ancient practices of using fire as a symbol of light, overcoming darkness, of renewal and hope. While modern fireworks are technological marvels, they tap into the same deep human connection to fire that has existed for millennia. The combination of traditional fire arts with contemporary pyrotechnics creates rich, layered celebrations that honor history while embracing innovation. Fire in all its forms, from a candle to a massive aerial shell, speaks to something fundamental in human nature. Some cultures have banned or restricted fireworks due to concerns. Not all places embrace fireworks enthusiastically. Environmental concerns about air pollution and the chemical residues fireworks leave behind have led some locations to restrict their use. Noise concerns, particularly regarding pets and wildlife, have prompted bans or limitations in certain areas. Some indigenous communities object to fireworks on their traditional lands. Fire danger during dry seasons makes fireworks too risky in many regions. These restrictions reflect evolving values and awareness of impacts that previous generations may not have considered. As alternatives, some places have turned to drone light shows or laser displays, technologies that can create visual spectacle without the noise, smoke, or chemical byproducts of fireworks. The future of fireworks may involve balancing tradition and enjoyment with environmental and social responsibility. Religious celebrations worldwide incorporate fireworks into ceremonies. Beyond national holidays, Religious celebrations often feature fireworks. Hindu, Buddhist, Christian, and Muslim celebrations all include fireworks in various cultural contexts. The symbolism varies, but often relates to themes of spiritual light, divine presence, or victory of good over evil. In Catholic countries, patron saint festivals feature fireworks as part of the honoring of holy figures. In Thailand, the Yi Peng festival includes fireworks alongside floating lanterns to honor Buddha. These religious contexts give fireworks deeper meaning beyond entertainment, connecting the earthly celebration to spiritual beliefs. The beauty of fireworks, their transformation of chemical materials into light, can be seen as metaphor for spiritual transformation or enlightenment. Fire has always held religious significance, and fireworks are a spectacular expression of that ancient sacred element. The modern fireworks industry. Fireworks manufacturing is concentrated in a few countries. While fireworks are used globally, their production is dominated by specific regions. China produces the vast majority of the world's fireworks, with entire cities dedicated to the industry. The expertise, infrastructure, and economic conditions make Chinese manufacturers highly competitive. The United States, Japan, Spain, and Italy also have significant fireworks industries, often focusing on specialized or high-end products. These countries have long traditions of pyrotechnic knowledge and skilled craftsmen. Manufacturing fireworks is labor-intensive and requires expertise in chemistry, engineering, and craftsmanship. It also requires regulatory compliance, as fireworks are classified as explosives and subject to strict oversight. The concentration of production means that fireworks travel considerable distances from where they are made to where they are used, creating a global supply chain. China exports billions of dollars in fireworks annually. The scale of Chinese fireworks production is enormous. Factories in regions like Hunan and Jiangxi provinces produce fireworks for the entire world. The industry employs hundreds of thousands of people, from those who mix chemicals, to those who assemble finished products, to those who design new effects. Chinese manufacturers produce everything from small consumer fireworks to massive professional shells. The expertise is deep, with knowledge passed through generations of families involved in the trade. Export markets include every continent, with major shipments to the United States, Europe, and throughout Asia. The dominance of Chinese production has economic benefits, but also raises concerns about safety standards, labor conditions, and the loss of traditional craft knowledge in other countries that once had thriving domestic industries. Safety regulations govern every aspect of production and sale. Fireworks are explosives, and as such are heavily regulated in most countries. Manufacturing facilities must meet strict standards for construction, storage, and handling. Chemicals are controlled, with restrictions on what can be used and in what quantities. Products must be tested and certified before sale. Labeling requirements ensure consumers understand what they are buying and how to use it safely. Professional pyrotechnicians must be licensed, demonstrating knowledge and competence. Display sites require permits and must meet safety standards regarding distances from spectators, structures, and flammable materials. These regulations exist because fireworks are genuinely dangerous when misused. They have prevented countless injuries and deaths. While regulations can seem burdensome to manufacturers and users, they represent learned lessons from past accidents and are essential to keeping celebrations safe. Consumer fireworks are limited in powder content for safety. The fireworks available to the general public are significantly less powerful than those used in professional displays. Regulations typically limit the amount of explosive composition in consumer items, restricting shell sizes, the types of effects allowed, and the materials that can be used. This ensures that even if something goes wrong, the consequences are less severe than they would be with professional-grade materials. Consumer fireworks are designed to be relatively foolproof, with long fuses, sturdy construction, and clear instructions. Despite these safeguards, injuries still occur when people ignore instructions, tamper with products, or use them while impaired. The restrictions on consumer fireworks are a compromise, allowing people to enjoy fireworks privately while minimizing risk. For those who want larger effects, attending professional displays remains the safer and more spectacular option. Professional shells can contain pounds of explosive composition. In contrast to consumer products, professional firework shells can be enormous. Large shells used in major displays may contain 10, 20, or even 50 pounds of pyrotechnic composition and explosive charges. The largest shells ever created have weighed hundreds of pounds and required specialized equipment to launch. These shells produce effects visible for miles and sounds heard across cities. They are expensive, costing hundreds or thousands of dollars each, and require expert handling. Only licensed professionals with proper training and equipment can use them. The power contained in these shells is immense, and mishandling could be fatal. Yet in the hands of skilled pyrotechnicians, following proper procedures, they are used safely to create the most impressive moments in fireworks displays, those bursts that fill the entire sky and take the breath away. Electronic firing systems have revolutionized display control. In the past, fireworks were fired manually, with pyrotechnicians lighting fuses by hand or using electrical matches connected to manual switches. This limited the precision of timing and required crew members to be close to the shells during firing. Modern electronic firing systems have changed everything. These systems use computerized controls to ignite shells with millisecond precision. A display can be pre-programmed entirely, with every shell assigned a specific firing time. The operator triggers the sequence from a safe distance, and the system handles the rest. This allows for choreography that would be impossible manually, such as synchronizing dozens of shells to burst at the exact same instant, or creating rapid fire sequences where shells launch fractions of a second apart. Electronic systems have made displays safer, more reliable, and far more sophisticated in their timing and coordination. Computer choreography allows precise timing with music. The integration of computers with fireworks has enabled a new art form, the fully choreographed display. Using specialized software, designers can plan entire shows down to individual shells, assigning each a precise firing time and position. The software can be synchronized with music, allowing designers to place bursts at specific beats, crescendos, or lyrics. Simulations show what the display will look like before a single shell is fired, allowing refinement and adjustment. The data is then loaded into the electronic firing system, which executes the plan with perfect timing. This technology has made possible the spectacular music-synchronized displays that have become common at major events. Every burst can be intentional, every pause calculated, every color choice deliberate. The result is a level of artistic control that elevates fireworks from simple spectacle to true performance art. Drone shows are emerging as alternatives to traditional fireworks. In recent years, illuminated drones flying in coordinated patterns have emerged as an alternative to fireworks. Hundreds or thousands of small drones, each equipped with LED lights, fly in formation, creating shapes, animations, and patterns in the sky. The drones are controlled by computer programs that choreograph their movements precisely. The advantages are significant: no smoke, no noise, no chemical waste, no fire danger, and the ability to create complex moving images impossible with fireworks. Drone shows can be performed in weather conditions that would ground fireworks and can fly in places where fireworks are prohibited. However, they lack some of the visceral impact of fireworks. There is no explosive energy, no surprise, no danger. The light is constant rather than bursting. For many, drones are a complement to fireworks rather than a replacement, each offering something the other cannot. The future may include new chemicals creating unprecedented colors. Research continues into new pyrotechnic formulations that could expand the palette of colors available. The challenge is finding compounds that are stable enough for safe handling and storage, that produce sufficiently bright colors when burned, and that do not create toxic byproducts. Scientists have experimented with various metal compounds and organic dyes. Some research focuses on producing pure blue, which remains difficult. Others seek truly bright, purple or other colors that are currently impossible or impractical. Any new formulations must pass rigorous safety testing and regulatory approval before they can be used. The process is slow, but progress continues. Future fireworks may include colors we have never seen before, expanding the pyrotechnician's palette and creating new possibilities for beauty in the night sky. Safety and environmental considerations. Fireworks accidents can cause serious injuries or death. Despite regulations and safety measures, fireworks remain dangerous. Every year, thousands of people are injured, some seriously. Burns, eye injuries, and hand injuries are common when fireworks are mishandled. Children are particularly vulnerable, as they may not understand the dangers or how to use products safely. Alcohol and fireworks are a deadly combination, with impaired judgment leading to reckless behavior. Accidents range from minor burns to loss of fingers or eyes to fatal incidents. The vast majority of accidents are preventable, caused by ignoring instructions, using damaged products, attempting to relight malfunctioning fireworks, or simply being too close. Public education campaigns emphasize safety, but the allure of fireworks and the excitement of celebration can lead to carelessness. Respecting fireworks as the explosive devices they are, rather than treating them as toys, is essential to preventing tragedy. Professional displays occasionally suffer malfunctions or accidents. Even professional shows, conducted by trained pyrotechnicians following strict protocols, sometimes go wrong. Shells can malfunction, bursting prematurely or not at all. Misfires can leave live shells in mortars, creating danger for cleanup crews. Shells can tip during launch, sending them into crowds or onto property. Wind can blow burning embers onto flammable materials, starting fires. Equipment failures can trigger unintended firing of shells. While professional accidents are relatively rare due to the expertise and procedures involved, when they occur, they can be serious. Large quantities of explosives are involved, and a major accident at a display can injure many people. Investigations after accidents typically reveal failures in procedure, equipment maintenance, or judgment. The lessons learned lead to improved practices, making future displays safer. Spectators should maintain safe distances from launch sites. One of the most important safety measures is keeping spectators far enough away from where fireworks are launched. Professional displays have exclusion zones, areas around mortars where no one is allowed. The size of this zone depends on the size of shells being fired, with larger shells requiring greater distance. These zones protect against several hazards: shells that tip and fire horizontally, debris from shells that explode prematurely, and fallout from the display, including hot ash and unexploded components. Even when everything functions perfectly, being too close is dangerous due to noise levels that can damage hearing and falling debris that can cause injury. Consumer fireworks also require safe distances, with instructions typically specifying how far observers should be from the device. Ignoring these distances turns celebration into risk, and every year people are injured because they were too close when something went wrong. Unexploded shells pose dangers and must be handled carefully. Not every firework that is launched functions as intended. Duds, shells that do not explode, fall back to Earth still containing live explosives. These unexploded ordnances are extremely dangerous. They may be unstable, capable of detonating if moved, struck, or heated. The proper procedure is to wait, typically at least 20 minutes, before approaching any shell that did not function. Even then, only trained personnel should handle them. Unexploded shells should never be picked up by civilians. They should be soaked in water if possible, and then disposed of according to regulations, often by controlled detonation in a safe location. Every year, people are injured or killed attempting to investigate or relight malfunctioning fireworks. The rule is simple and absolute. Never approach or touch an unexploded firework. Environmental impacts. Smoke from fireworks temporarily affects air quality. When thousands of fireworks burst over a short period, they release significant amounts of smoke and particulate matter into the air. This smoke consists of fine particles, metal compounds, and combustion byproducts. Air quality can decline noticeably during and after major displays, with pollution levels spiking temporarily. For most people, this short-term exposure causes no lasting harm, though it can irritate eyes and airways. However, individuals with respiratory conditions like asthma may experience difficulty breathing. The pollution typically disperses within hours as wind carries it away and particles settle. The impact is temporary and localized, but it is measurable. In areas with poor air quality or during temperature inversions that trap air near the ground, fireworks can contribute to problematic pollution levels. Some cities monitor air quality around major displays and issue health advisories when necessary. Heavy metals from fireworks can accumulate in soil and water. The compounds that create beautiful colors in fireworks contain metals: strontium, barium, copper, aluminum, and others. When shells burst, these materials are dispersed as fine particles that eventually fall to the ground or into water. Over time and with repeated displays, measurable amounts of these metals can accumulate in soil near launch sites or in bodies of water where debris falls. While the concentrations are generally low and the metals are not in their most toxic forms, the accumulation is a concern. Some metals can be absorbed by plants or enter aquatic ecosystems. Long-term effects are not fully understood, but research is ongoing. The fireworks industry has responded by working to reduce or eliminate the most problematic compounds and by developing cleaner burning formulations that leave less residue. The goal is to maintain the spectacle while minimizing the environmental footprint. Perchlorates from fireworks can contaminate water supplies. One of the more concerning chemicals in fireworks is perchlorate, often used as an oxidizer in pyrotechnic compositions. Perchlorates are highly soluble in water, and when firework debris falls into watersheds or onto soil that drains to water sources, perchlorate can enter drinking water supplies. In high concentrations, perchlorate can interfere with thyroid function, a particular concern for pregnant women and children. Regulatory agencies in some countries have set limits on perchlorate in drinking water, and contamination from fireworks has been documented in some areas. The fireworks industry has explored alternatives to perchlorate, but finding compounds that work as effectively while being safer is challenging. Some manufacturers have developed low perchlorate or perchlorate-free formulations, though these are not yet universal. Proper site selection for displays, Keeping them away from sensitive watersheds helps minimize this risk. Wildlife and pets are often distressed by loud firework sounds. The bangs and booms that humans find thrilling can be terrifying for animals. Domestic pets may panic during fireworks displays, exhibiting signs of extreme stress. Dogs may try to flee, sometimes injuring themselves or becoming lost. Cats may hide and refuse to eat. Wildlife is also affected. Birds may be flushed from roosts at night, disrupting sleep and increasing predation risk. Some species have been documented abandoning nests in response to fireworks. Marine mammals can be affected by fireworks over or near water, the sounds carrying through the sea. Farm animals may stampede or injure themselves. While the distress is temporary, it is real, and for some animals, repeated exposure can cause lasting anxiety. Some people and communities have responded by using quieter fireworks or scheduling displays to minimize impact on sensitive areas or times, such as avoiding displays during nesting seasons. Efforts are underway to develop cleaner burning formulations. Awareness of environmental issues has prompted research into making fireworks less harmful. Cleaner burning means reducing smoke production, eliminating toxic metals, and minimizing residue. Some progress has been made. Nitrogen-rich compounds can reduce smoke while maintaining performance. Alternative colorants that do not contain heavy metals are being explored. Biodegradable materials for casings and components reduce persistent debris. Some manufacturers advertise green fireworks or environmentally friendly options, though these claims vary in their accuracy and scope. True improvement requires balancing environmental concerns with performance, cost, and safety. A firework that is environmentally perfect but does not create the desired effect, or that is too expensive for widespread adoption, will not replace conventional products. The challenge is creating formulations that are genuinely better while remaining practical. Progress continues, driven by both regulation and market demand. Some locations have moved toward lower noise alternatives in response to concerns about noise, particularly regarding effects on animals and sensitive populations. Some places have begun featuring quiet fireworks displays. These shows emphasize visual effects while minimizing loud bangs. Shells are designed to burst beautifully, but without including salutes or other sound-producing devices. The result is a gentler experience that still provides spectacle without the jarring explosions. Some audiences appreciate the change, finding the quieter displays more relaxing and inclusive. Others feel that eliminating sound removes an essential part of the experience, that fireworks should be loud and startling. The debate reflects differing values about what fireworks should be and who they are for. Quiet fireworks represent a compromise, attempting to preserve tradition while adapting to contemporary concerns. Laser shows and projection mapping offer visual alternatives. Beyond drones, other technologies can create nighttime visual spectacle. Laser shows use powerful beams of colored light to draw patterns and images in the sky or on surfaces. Projection mapping uses video projectors to cover buildings or structures with animated imagery, transforming architecture into dynamic displays. Water screen projections shoot water into the air and project images onto the resulting mist. These technologies create impressive effects without explosions, smoke, or noise. They can be precisely controlled, repeating perfectly, and can incorporate complex animations and storytelling. However, they lack the ephemeral, elemental quality of fireworks. A laser is cold, light, precise but without the warmth and chaos of fire. For some occasions and audiences, these alternatives are perfect. For others, nothing can replace the experience of watching fire bloom in the darkness above. The psychology of fireworks. Humans are drawn to fire on a primal level. Our relationship with fire is ancient, predating civilization itself. Fire provided warmth, protection from predators, a way to cook food, and light in darkness. For hundreds of thousands of years, human survival depended on mastering fire. This deep history has left psychological imprints. Watching fire is mesmerizing, holding attention in a way few other things can. The dancing flames, the colors, the warmth, all speak to something fundamental in us. Fireworks tap into this ancient attraction. They are fire, but elevated to spectacular heights. They combine the primal draw of fire with novelty, color, and sound in ways our ancestors could never have imagined. When we watch fireworks, we are experiencing something both utterly modern and deeply ancient. Technology in service of an instinct millions of years old. The surprise of explosions triggers excitement and joy. Part of the appeal of fireworks is their unpredictability and suddenness. Even in choreographed displays, each burst is a surprise, appearing instantly from nothing. This sudden stimulation triggers neurological responses. The brain releases adrenaline and dopamine, chemicals associated with excitement and pleasure. The startle response, normally associated with threats, becomes enjoyable in the safe context of a celebration. We know we are safe, so the adrenaline becomes thrilling rather than frightening. Children often squeal and clap. Adults gasp or cheer. These are genuine, involuntary reactions to stimulation that is intense but joyful. Fireworks create moments of pure presence, where attention is fully captured and the mind is not wandering. In our distracted age, this complete absorption is increasingly rare and valuable. Shared experiences create social bonding and community. Fireworks are typically public events experienced with others. Crowds gather, neighbors meet, families reunite. The shared experience of watching something beautiful together creates social bonds. Strangers standing side by side react in unison, gasping at the same moment, laughing at the same burst. This collective experience reinforces social connections and creates a sense of community. After the display, people talk about what they saw, sharing favorite moments. Children remember watching fireworks with grandparents. Couples share romantic moments under the lights. These memories become part of personal and communal identity. The social dimension is as important as the spectacle itself. Fireworks are not meant to be watched alone, but to be shared, creating common experience that ties individuals into groups and communities. Anticipation builds as the first shells are loaded and launched. Before the display begins, anticipation is palpable. People find their spots, settle in, and wait for darkness to deepen. Conversation is expectant, speculative about what will be shown. Children are restless with excitement. When the first shells finally launch, trailing sparks as they climb, the waiting pays off. Each burst satisfies while creating anticipation for the next. Between shells, the audience wonders what is coming. Will it be bigger? A different color? As the display progresses, anticipation builds toward the finale, everyone knowing that the best is yet to come. This structure of anticipation, satisfaction, and renewed anticipation is fundamental to the fireworks experience. It keeps attention engaged and creates an emotional arc that makes the experience memorable. The finale creates a peak emotional experience. The finale is designed to be overwhelming, to create a moment of such intensity that it eclipses everything that came before. When executed well, the finale produces a peak emotional experience, a moment that stands out in memory. The sheer volume of stimulation pushes consciousness into a different state, one of pure sensory experience without analysis or thought. Time seems to slow or become irrelevant. The self fades, leaving only the experience. These peak moments are what people remember most strongly. Days, years later, people recall the finale of a particularly impressive display, the awe and wonder it provoked. This is why pyrotechnicians invest so heavily in finales, why the last minute of a show might cost more than the previous 15 minutes combined. Creating that peak experience is the goal, leaving spectators with a memory they will carry forward. Memories of fireworks become markers of important moments. Because fireworks are associated with celebrations, they become embedded in memory as markers of significant times. People remember fireworks from childhood Independence Day celebrations, or from a wedding, or from a trip to a new city. The memory of the fireworks becomes intertwined with the memory of the event and the people involved. Years later, a burst of color in the sky can trigger recollection of a specific moment, a specific feeling. This mnemonic power makes fireworks more than entertainment. They are tools for creating lasting memories, for marking time, for anchoring important experiences in sensory detail. The combination of visual beauty, sound, shared experience, and emotional intensity creates memories that persist, becoming part of the story of our lives. Some find fireworks stressful rather than enjoyable. While many people love fireworks, they are not universally enjoyed. For individuals with certain anxieties, sensory processing issues, or trauma histories, fireworks can be distressing rather than delightful. The loud sounds can trigger panic in those with conditions like post-traumatic stress disorder. The crowds and noise can overwhelm people with autism or sensory sensitivities. Some simply find the explosions jarring rather than exciting. For these individuals, what is a celebration for others is an ordeal to be endured or avoided. Increasing awareness of these issues has led to efforts to make firework events more inclusive, such as designating quiet viewing areas, providing advance notice of displays so people can prepare, or offering sensory-friendly alternative events. Recognizing that not everyone experiences fireworks the same way is important for creating celebrations that can be enjoyed by entire communities. Cultural meanings shape how fireworks are experienced. The experience of fireworks is not universal, but culturally situated. In cultures where fireworks mark joyous occasions and are associated with positive memories, people experience them with pleasure and nostalgia. In places where fireworks might be associated with conflict or have been used in warfare, the sounds might evoke fear rather than joy. The meanings attached to colors, symbols, and specific effects vary across cultures. Red might be lucky in one culture and aggressive in another. The social context, whether a fireworks display is a shared public good or a private show of wealth, affects how it is perceived. Understanding these cultural dimensions reminds us that while fire and light are universal, the meanings we create around them are learned and shared within communities. The craft of pyrotechnics. Becoming a licensed pyrotechnician requires training and experience. Professional pyrotechnics is a skilled trade requiring knowledge of chemistry, engineering, safety procedures, and practical techniques. Training typically involves a combination of classroom learning and apprenticeship under experienced professionals. Trainees learn about different types of fireworks, how they function, how to handle them safely, and how to design and execute displays. They study regulations and legal requirements. They practice physical tasks like setting up mortars, loading shells, and connecting firing systems. Licensing requires demonstrating competence, often through written examinations and practical assessments. Different levels of certification allow pyrotechnicians to handle increasingly complex and powerful displays. The training is rigorous because the work is dangerous and mistakes can be deadly. Those who complete the training join a community of craftspeople who take pride in their expertise and their ability to create wonder safely. Master pyrotechnicians guard their secret formulas closely. Within the pyrotechnics community, knowledge is often proprietary. Craftspeople develop formulas through years of experimentation, tweaking ingredients and proportions to achieve specific effects. These formulas are valuable intellectual property, the competitive advantage that distinguishes one maker from another. A particularly beautiful shade of blue or a strobe that pulses with perfect regularity might be the result of small adjustments known only to the creator. While basic pyrotechnic chemistry is publicly available, the details that separate good fireworks from exceptional ones are often secret. Master pyrotechnicians may pass their knowledge only to trusted apprentices, maintaining traditions of craft secrecy that go back centuries. This creates a tension between the desire to advance the field through shared knowledge and the desire to protect individual expertise and competitive position. Testing new effects requires isolation and safety protocols. Innovation in fireworks means creating new chemical formulations and testing them to see what happens. This is inherently dangerous work. A new mixture might burn as expected, or it might explode violently, or it might not work at all. Testing is done in remote locations, in bunkers, or behind barriers that can contain an explosion. Only small quantities are tested at first. Detailed records are kept of what was tried and what resulted. Safety equipment is essential: protective clothing, distance, and shields. Even with precautions, testing is risky. There have been accidents, injuries, and fatalities over the centuries of fireworks development. Yet testing continues because innovation is valued. Each new effect, each improvement in color or duration or reliability represents progress. The pyrotechnicians who do this work accept the risks as part of the craft, taking satisfaction in pushing the boundaries of what is possible. Traditional methods coexist with modern technology in the craft. The fireworks industry straddles tradition and modernity. Some aspects of production remain largely unchanged from centuries ago. Stars are still rolled or pressed by hand in some workshops. Shells are still assembled layer by layer. The hands-on craftsmanship, the judgment of experienced eyes and fingers, remains essential. At the same time, computer modeling predicts how formulas will perform. Precision scales measure ingredients. Electronic firing systems control displays. The most successful operations blend old and new, using technology to enhance rather than replace traditional skills. A craftsperson with decades of experience working with state-of-the-art tools can achieve results neither tradition nor technology alone could produce. This balance is part of what makes pyrotechnics a living craft, rooted in history but adapting to the present. Pyrotechnicians must understand chemistry, physics, and engineering. Creating effective fireworks requires knowledge across multiple disciplines. Chemistry governs the reactions that produce color, heat, and gas. Understanding reaction rates, energy release, and the behavior of different compounds is fundamental. Physics explains how shells travel, how stars disperse, and how sound propagates. Engineering principles guide the design of mortars, shells, and firing systems. Materials science informs choices about casings and structural components. Even weather knowledge is important, as wind, humidity, and temperature affect performance. A successful pyrotechnician is part chemist, part engineer, part artist, and part technician. The interdisciplinary nature of the work attracts people who enjoy complexity and problem-solving, who find satisfaction in applying knowledge from multiple fields to create something beautiful and exciting. The work is physically demanding and often done in difficult conditions. Pyrotechnics is not just intellectual work, but physical labor. Setting up a display involves hauling heavy mortars, positioning them precisely, loading shells, and running wiring or fusing. This often happens in heat, in cold, in darkness, or in other challenging conditions. Display sites may be muddy fields, steep hillsides, or crowded urban areas. The work requires strength, stamina, and the ability to focus despite discomfort. Time pressure is common, with setups often occurring in the hours before a show. Once the display begins, the work continues, with technicians monitoring equipment, tracking the sequence, and being ready to respond to problems. After the show, the site must be cleaned, a process that includes searching for unexploded shells and removing debris. It is work that is exhausting but exhilarating, especially when a display goes perfectly. Mistakes in measurement or assembly can have serious consequences. Precision matters in fireworks. A mistake in weighing ingredients can make a star burn too fast or too slow, or create a dangerous mixture. An error in assembling a shell can cause it to explode prematurely, or not at all. Incorrect loading can send a shell sideways instead of up. Faulty fusing can cause unexpected timing. Many mistakes result in nothing worse than a disappointing effect, but some can cause accidents. A shell bursting in its mortar, a fire, injuries. The consequences of error reinforce the importance of training, attention to detail, and following procedures. Experienced pyrotechnicians develop routines and checklists to minimize mistakes. They work carefully, double-checking their work. The combination of danger and beauty in the work demands respect, a recognition that carelessness can turn celebration into tragedy. Success is measured in gasps and applause from the crowd. For pyrotechnicians, the reward is not wealth, as the work is often seasonal and modestly paid. The reward is the reaction of the audience. When a shell bursts and the crowd gasps in unison, that is success. When the finale ends and applause erupts, that is the payment that matters. Pyrotechnicians rarely watch their own displays from the spectator perspective, instead monitoring equipment and staying focused on the next launch. But they hear the crowd, the exclamations of wonder, the cheers. They know when a shell worked perfectly because they hear the response. Creating moments of joy and amazement for hundreds or thousands of people is deeply satisfying work. Each display is a performance, ephemeral and unique, and the immediate feedback from the audience provides affirmation. This is why people stay in the field despite the hard work and modest pay, for the satisfaction of creating beauty that brings communities together in shared wonder. Fireworks in culture and history. Ancient Chinese emperors commissioned massive displays of wealth and power. In imperial China, fireworks were not merely entertainment, but symbols of authority. Emperors commanded displays of unprecedented scale to demonstrate their wealth and the sophistication of their courts. Thousands of fireworks might be used in a single evening. Elaborate frameworks shaped like dragons, pagodas, or legendary scenes would be constructed and set ablaze. These displays asserted power, showing that the emperor commanded resources and craftsmanship that others could not match. They also served diplomatic purposes, impressing foreign visitors with Chinese technological superiority. The tradition established fireworks as objects of prestige, tools of statecraft as much as celebration. This legacy continues in modern China, where major displays are points of national pride. European royalty used fireworks to celebrate military victories. In Europe, from the Renaissance onward, fireworks marked important state occasions. Victories in war, were commemorated with displays that symbolically reenacted battles, with fireworks representing cannons and explosions. These were propaganda events, reinforcing the power of the crown and the glory of the nation. Artists and architects designed elaborate temporary structures specifically for these occasions. Engravings and paintings documented the events, spreading the imagery beyond those who could attend. The pyrotechnicians who created these displays were sought after, moving between royal courts and competing for patronage. Fireworks became associated with power and prestige, an association that persists. Major modern displays for inaugurations or national celebrations echo this history, using fireworks to signal importance and to create spectacle that asserts authority. Fireworks marked the signing of the Declaration of Independence. In the United States, fireworks have been tied to Independence Day since the very beginning. John Adams, in a letter written just after the Declaration of Independence was approved, predicted that the occasion would be celebrated with fireworks and illuminations. His vision proved accurate. The first Independence Day celebrations in 1776 included fireworks in Philadelphia and other cities. The tradition took root, and fireworks became the defining feature of 4th of July celebrations. This association between fireworks and American independence is so strong that many Americans think of fireworks primarily in terms of the 4th of July. The tradition reflects the appropriation of a Chinese invention by a new nation, using fire and light to celebrate freedom and beginning. The Grucci family has created legendary displays for generations. In the world of professional pyrotechnics, certain names carry weight, and Grucci is one of the most renowned. The Grucci family has been involved in fireworks for generations, creating displays for presidents, popes, and royal families. Their shows have set records and won awards. They have innovated techniques and effects that have become industry standards. The family passes knowledge and craft from one generation to the next, maintaining traditions while embracing innovation. Their work represents the pinnacle of what is possible in fireworks, combining technical excellence with artistic vision. For those in the pyrotechnics community, working with or learning from the Gruccis is a mark of distinction. Their legacy is a testament to the depth of skill and dedication that the craft can inspire. Fireworks have appeared in art, literature, and film for centuries. The visual impact and symbolic resonance of fireworks have made them popular subjects in creative works. Painters have captured the explosions of light and color, from impressionistic sketches to detailed technical illustrations. Poets have used fireworks as metaphors for beauty, ephemerality, and passion. Novelists describe displays to mark important moments in characters' lives. In film, fireworks signal romance, celebration, or finales. Their appearance often carries symbolic weight, representing release, joy, or the climax of action. The 1812 Overture by Tchaikovsky famously incorporates cannon fire and fireworks into orchestral music. This presence in art across media reflects the cultural significance of fireworks, the way they capture something essential about human celebration, and the desire to mark important moments with beauty and spectacle. Katy Perry's song brought fireworks into contemporary pop culture. In contemporary culture, the song Firework by Katy Perry became an anthem of self-empowerment and celebration. The lyrics use fireworks as a metaphor for individual potential and uniqueness, for the idea that everyone has the capacity to shine brilliantly. The music video features fireworks prominently, including bursts emanating from the singer herself. The song was hugely successful and has been adopted for various celebrations and empowerment campaigns. Its cultural impact demonstrates how fireworks continue to function as symbols, carrying meanings beyond the physical objects themselves. In this case, fireworks represent self-expression, joy, and the idea that one can make a spectacular impact on the world. The song added a new layer to the cultural meanings of fireworks, connecting them to personal identity and empowerment in ways that resonate particularly with younger generations. Personal experiences and memories. Many people remember their first fireworks display vividly. There is something about the first time that imprints deeply. Perhaps it is the sheer novelty, the unexpected intensity of sound and light. Children especially carry these memories forward. The mixture of fear and excitement, clinging to a parent's hand while watching the sky explode in colors. The visceral reaction to the first bang, the surprise that quickly transforms into delight. Years later, adults can often recall details: where they sat, who they were with, the smell of summer grass and gunpowder smoke, the taste of cotton candy or popcorn. These first experiences create a template, establishing what fireworks mean emotionally. Every subsequent display is measured against that first one. And even when larger or more sophisticated shows are seen later, the first often retains a special place in memory because it was when wonder was newest. Families create traditions around annual fireworks events. For many families, attending fireworks displays becomes a cherished tradition, repeated year after year. They return to the same spot, set up the same blanket, bring the same snacks. Children grow up with these traditions, the rhythm of the year marked by the anticipation of the fireworks show. Siblings create games or competitions around predicting which shell will burst next or which color will appear. Parents point out particularly impressive bursts, narrating the display for younger children. As those children become adults and have their own families, they often continue the tradition, bringing a new generation to the same field or beach or park. The continuity creates a sense of belonging and rootedness, connecting individuals to family history and community. The fireworks themselves are just part of the experience. The tradition and togetherness are equally important. Couples often share romantic moments during displays. Fireworks have a romantic quality, their beauty creating a sense of occasion. Couples on dates watch displays together, the darkness and the spectacle creating intimacy. Marriage proposals have been made under bursting shells, the explosions of color providing a dramatic backdrop to a life-changing question. Anniversaries are celebrated with trips to see fireworks. The combination of beauty, excitement, and the natural pauses between shells that create space for closeness makes fireworks a romantic setting. The fact that fireworks are temporary, that they exist only for moments, adds poignancy. The experience is shared but unrepeatable, each display unique, much like the moments that make up a relationship. For many, certain displays become milestones, anniversaries in their own right, remembered as markers of relationship progression. Veterans may have complicated feelings about explosions. For individuals who have experienced warfare, the sounds of fireworks can be deeply troubling. The bangs and whistles can trigger traumatic memories, causing flashbacks or anxiety. The brain, trained to react to explosion sounds as signals of danger, does not easily distinguish between celebratory fireworks and combat. This is not weakness or overreaction, but a physiological response to trauma. Many veterans avoid fireworks displays, staying indoors with music or white noise to mask the sounds. Some communities have begun to acknowledge this issue, asking neighbors to be considerate, providing advance warning of displays, or creating designated quiet zones. The recognition that what is a celebration for some is a source of pain for others represents growing awareness and compassion. It reminds us that experiences are not universal, that we share space with people whose histories shape their present in profound ways. Children with sensory issues may find displays overwhelming. For children with autism or sensory processing disorders, fireworks can present significant challenges. The loud sounds are not just unpleasant, but actually painful, overwhelming sensory systems that are already sensitive. The crowds, the darkness, the unpredictability of when the next explosion will occur, all create anxiety. What is intended as family fun becomes an ordeal. Parents of children with these challenges often skip fireworks or seek out alternative experiences. Some communities now offer sensory-friendly fireworks shows, with lower noise levels, quieter locations, and support services available. These adaptations allow children who would otherwise be excluded to participate in celebrations. The effort to make fireworks accessible to everyone reflects a broader shift toward inclusive community events that consider diverse needs and experiences. Pets hiding in fear become part of the fireworks ritual for many. For pet owners, fireworks season is a time of concern. Dogs and cats often react with terror to the sounds, hiding under beds, in closets, or attempting to flee. The anxiety is real and distressing for the animals. Owners prepare by creating safe spaces, using anxiety wraps or calming medications, staying home to comfort frightened pets. The need to care for distressed animals becomes part of the fireworks experience, adding responsibility to what might otherwise be carefree celebration. Some people choose to skip displays to stay with their pets. Others bring animals to quieter locations or time their attendance to avoid the loudest portions. This aspect of fireworks, the impact on animals, adds complexity to what might seem like straightforward fun, requiring consideration and compassion alongside enjoyment. Photographers capture displays in ways eyes alone cannot. Fireworks photography is its own art form, capturing the explosions of light in images that sometimes reveal more than direct observation. Long exposure photography allows multiple bursts to be captured in a single frame, creating images where the sky is filled with overlapping effects that never existed simultaneously. Time-lapse sequences show the evolution of displays compressed into seconds. High-speed photography freezes individual moments, showing the structure of bursts in detail impossible to see in real time. These images become iconic, representing displays and events long after the smoke has cleared. They also democratize the experience, allowing people who could not attend to see what happened. The photographer becomes a mediator, interpreting the display through choices of framing, exposure, and timing, creating a version of the event that is both document and art. The smoke, lingering after a display, has a distinctive smell. After the finale, when the lights are gone and silence returns, the smell remains. The acrid, sulfurous scent of spent gunpowder, mixed with burnt paper and metal compounds, hangs in the air, drifting through the crowd as people pack up and leave. For many, this smell is as much a part of the experience as the visual spectacle. It is the olfactory signature of fireworks, instantly recognizable and strongly tied to memory. Smelling this particular combination at other times can trigger recollection of specific displays, specific moments. The smell is not exactly pleasant, being harsh and chemical, but it is not entirely unpleasant either. It is distinct, and its association with celebration gives it positive valence, despite its acrid nature. As people walk to their cars or head home, carrying that smell with them, they carry also the memory of what they have witnessed. Some watch from boats, seeing displays reflected in water. Fireworks over water create doubled beauty, the bursts mirrored on the surface below. Cities with harbors or lakes often cite displays to take advantage of this effect. Spectators on boats have privileged views, seeing the fireworks from unique angles and experiencing the show surrounded by water. The reflections can be stunning, especially when the water is calm. Each burst appears twice, once in the sky and once inverted below, creating symmetry. The sound also changes over water, echoing differently, adding depth and dimension. Watching from a boat creates a sense of isolation and intimacy, separated from the crowds on shore. The gentle motion of the water, the coolness of the air over the surface, the sight of city lights in the distance, all combine with the fireworks to create an experience that is both grand and peaceful. Watching from high buildings offers a unique perspective. In cities, some people watch fireworks from rooftops or high-rise windows, looking down on or across at the displays. This perspective is disorienting in the best way, seeing bursts at eye level or even below rather than overhead. The sense of scale changes, with large shells appearing smaller and more delicate when seen from altitude. The patterns of the bursts are more visible from above, showing the symmetry and structure that can be harder to appreciate from ground level. The sounds reach the observer differently, slightly delayed and softened by distance. Multiple displays across the city might be visible simultaneously, creating a landscape of light. This perspective is rare, available only to those with access to tall buildings, and it offers a version of the fireworks experience that feels exclusive and special, a secret show within the public show. The physics behind the spectacle. Gravity pulls stars downward, curving their trajectories. When a shell bursts, the stars are thrown outward in all directions with significant force. If no other force is acted on them, they would travel in straight lines away from the burst point. But gravity immediately begins pulling them downward, bending their paths into curves. The higher and faster a star is moving, the longer it takes for gravity to bring it down, but eventually all stars fall. This is why the shapes of fireworks evolve over time. A peony starts as a perfect sphere, but gravity pulls the lower stars down faster than the upper ones, distorting the shape. Pyrotechnicians account for this in their designs, knowing that the pattern will change as it spreads and falls. The interplay between the initial outward force and the constant downward pull of gravity creates the graceful arcs and curves that make fireworks beautiful. Air resistance slows stars and affects how far they travel. The stars flying through the air are not in a vacuum. They encounter air resistance, also called drag, which opposes their motion. The faster a star moves, the more drag it experiences. Drag depends also on the star's size and shape. Small, dense stars experience less drag relative to their mass and travel farther. Large, light stars slow quickly. This is why some stars travel far from the burst point, while others seem to hover nearby. Drag also affects how stars burn. As they move through air, the airflow supplies oxygen that supports combustion, but also cools the surface. The balance determines burn rate. Pyrotechnicians must account for drag when designing effects, understanding that what works at ground level will behave differently when traveling at high speed through the sky. Wind can push an entire display off course. Wind is one of the biggest unpredictable factors in fireworks displays. At ground level, wind may be barely noticeable, but at altitude, it can be strong. Shells ascending hundreds of feet may encounter different wind speeds and directions at different heights. This can cause shells to drift from their intended positions, sometimes significantly. If wind is strong enough, an entire display can be pushed downwind, putting bursts over areas where they were not intended, potentially over crowds or structures. Pyrotechnicians monitor wind conditions carefully before and during shows. If conditions are dangerous, displays may be delayed or cancelled. Techniques like angling mortars into the wind can compensate to some degree, but there are limits. Strong, variable winds make precise choreography difficult. The wind adds an element of unpredictability, reminding us that for all our control, nature still plays a role. Temperature affects the burn rate of firework compositions. Chemical reactions are temperature dependent, proceeding faster when warm and slower when cold. Fireworks are no exception. The same shell that performs perfectly on a warm summer evening may behave differently in cold weather. Compositions burn more slowly, stars may burn longer or not as brightly, and fuses may not time correctly. This can throw off carefully planned choreography. Cold can also affect the physical properties of components, making casings more brittle or causing separation in layered compositions. Very hot weather presents different challenges, potentially increasing sensitivity or causing formulations to degrade. Professional pyrotechnicians adjust for expected temperatures when planning displays, sometimes modifying formulas or timing to account for conditions. Despite these efforts, temperature variations remain a challenge, particularly for shows that span multiple hours or occur in places with large day-to-night temperature swings. Humidity impacts color, intensity, and smoke production. The amount of water vapor in the air affects how fireworks burn. High humidity can dampen powder composition slightly, potentially slowing burn rates or affecting ignition. It can also increase the amount of smoke produced, as water vapor condenses around particles, creating more visible smoke. On the positive side, humidity can intensify certain colors, particularly reds and oranges, as the moisture affects the emission spectra of burning metals. Dry conditions lead to cleaner burning with less smoke, but can also increase fire danger from falling debris. The ideal humidity is moderate, enough to minimize fire risk without significantly affecting performance. Like temperature, humidity is largely beyond the pyrotechnician's control, another variable to be monitored and adapted to rather than controlled. Weather forecasts become important tools in planning, helping anticipate conditions and make adjustments. The Doppler effect changes the pitch of whistles as shells ascend. Whistling fireworks that rise through the air demonstrate an interesting physical phenomenon. As a whistling shell moves upward, the sound waves it emits are compressed in the direction of motion and stretched behind. To an observer on the ground, this causes the pitch to rise slightly as the shell approaches and fall as it moves away, though the shell is actually moving across the sky rather than toward or away from the observer in most cases. The effect is subtle with fireworks, much less dramatic than with passing vehicles, but it is present. The physics is the same as with the Doppler effect that causes sirens to drop in pitch as ambulances pass. For those who pay attention, this tiny detail adds another layer of physical reality to the experience. A reminder that fireworks are not just chemistry, but physics, subject to the same laws that govern everything else in motion. Momentum conservation determines how stars spread from bursts. When a shell explodes, the chemical reaction converts the chemical energy stored in the explosive into kinetic energy and heat. This energy accelerates the stars and shell casing fragments outward. The principle of conservation of momentum means that the total momentum of all these pieces equals the momentum of the shell just before it burst. The distribution of that momentum among the pieces depends on their masses and the geometry of the explosion. Heavier stars receive less velocity than lighter ones if the force is equal. The shape of the bursting charge affects how force is distributed, allowing pyrotechnicians to create asymmetric effects if desired. Understanding momentum and energy allows precise control over effects, determining how large the burst will be, how fast the stars will travel, and how the pattern will develop. Acoustic echoes create the rolling thunder after large salutes. The bang of a large salute is not simply a single sound, but a complex acoustic event. The initial shockwave travels outward at the speed of sound, reaching nearby observers first. But the sound also bounces off surfaces, buildings, hills, water, and these reflections return as echoes. The result is a sound that rolls and rumbles, lasting seconds after the initial bang. In cities with tall buildings, multiple echoes from different directions overlap, creating a confusion of sound that can be disorienting. Over open water or flat plains, fewer echoes mean a sharper, cleaner sound. The acoustic environment shapes the auditory experience of fireworks as much as the fireworks themselves. Pyrotechnicians working in new venues scout the acoustics, testing how sound behaves in the space, using that information to plan effects that will sound good in that particular environment. The future of fireworks. Biodegradable materials may replace traditional casings. Environmental concerns are driving innovation in fireworks materials. Traditional shell casings are made of paper or cardboard, which are biodegradable, but some modern fireworks use plastic components for strength or cost reasons. There is growing interest in ensuring all materials decompose naturally. Research is exploring bioplastics and other materials that provide necessary strength while breaking down after use. The goal is for fireworks to leave no persistent debris, with everything either consumed in the burning or decomposing naturally within a reasonable time. Some manufacturers now market green fireworks that use biodegradable materials throughout. The challenge is maintaining performance while switching materials, ensuring that new casings are strong enough and that they do not affect how the firework burns or bursts. Regulations may require quieter formulations to protect wildlife. As awareness of wildlife impacts grows, regulatory pressure may force changes in how fireworks sound. Some jurisdictions are already implementing restrictions on noise levels or time of day for displays. Future regulations might ban the loudest salutes or require that a certain percentage of shells be low-noise variants. The fireworks industry would need to adapt, focusing more on visual effects and finding ways to create excitement without relying on loud bangs. This would represent a significant shift in the character of displays, potentially changing what fireworks mean culturally. However, it could also drive innovation, leading to new visual effects that replace sound as the primary source of thrill and surprise. The balance between preserving tradition and protecting environmental and animal welfare is ongoing and will continue to shape how fireworks evolve. Virtual reality might allow people to experience displays from impossible perspectives. Technology offers new ways to experience fireworks. Virtual reality could place viewers inside a display, surrounded by bursts, or give them a bird's-eye view from above. Cameras mounted on drones could provide real-time footage from within the bursts themselves, showing structures and colors from angles never seen before. Augmented reality could overlay information on live displays, identifying shells as they burst, or showing what is coming next. These technologies would not replace attending displays in person, but could supplement the experience or make it accessible to those who cannot attend physically. The sense of presence and wonder that fireworks create might be enhanced through technology, allowing new forms of appreciation and understanding. The intersection of old and new, ancient chemistry, and cutting-edge digital technology could create experiences that are both traditional and innovative. Advances in chemistry may produce entirely new colors and effects. The palette of fireworks has expanded over centuries, but challenges remain. Pure purple is still difficult. Bright blue requires specific conditions. Researchers continue exploring new compounds that might produce colors currently impossible or impractical. Advances in materials science might allow stars that burn longer or brighter. New binding agents could create more complex, structured burns. The integration of nanotechnology might allow incredibly precise control over how compositions burn at microscopic scales. Each advance opens possibilities for effects that have never been seen, combinations of color, duration, and pattern that are currently impossible. The future of fireworks may include spectacles that would seem like magic to today's pyrotechnicians, just as today's displays would amaze those from a century ago. Drones might deliver and trigger fireworks at precise aerial points. An emerging concept is using drones not as replacements for fireworks, but as delivery mechanisms. Imagine drones flying to specific points in the sky and triggering fireworks at exactly the right moment and location. This would allow unprecedented control over where bursts occur, creating three-dimensional choreography that fills specific volumes of space, rather than launching from fixed points. Shells could be placed to spell out words or create animations that move through space. The precision of computer-controlled drones combined with the beauty of traditional fireworks could create hybrid shows unlike anything possible with current technology. Technical challenges are significant, including safety systems to ensure drones do not crash or misfire fireworks. But the potential is intriguing. Such systems could revolutionize display design, giving pyrotechnicians tools to create effects currently impossible. Artificial intelligence could design displays optimized for audience emotion. As artificial intelligence advances, it might be applied to fireworks choreography. AI could analyze successful displays, learning what sequences of effects, timings, and colors create the strongest emotional responses in audiences. It could then generate new displays optimized for maximum impact. Sensors could even provide real-time feedback during shows, with AI adjusting the remaining sequence based on how the crowd is responding. This raises interesting questions about art and human judgment. Would an AI-designed display be better or worse than one created by human expertise and intuition? Would something be lost if creativity is delegated to algorithms? Or could AI be a tool that frees human designers to focus on higher-level artistic decisions while the software handles technical details? The integration of AI into pyrotechnics is speculative but not implausible, part of the broader question of how technology and tradition coexist. Global competitions push the boundaries of what is possible. International fireworks competitions, held in cities around the world, drive innovation and excellence. Teams from different countries compete, showcasing their best work and newest techniques. Judges and audiences compare displays, and winners receive recognition and prestige. These competitions create incentive to push boundaries, to attempt effects never tried before, to take risks. They also facilitate exchange of ideas and techniques, as pyrotechnicians see what their peers are doing and adapt successful innovations. The competitive environment accelerates the evolution of the art form. What might take decades to develop in isolation happens in years, when craftspeople worldwide are striving to outdo each other. The result is a continuous raising of standards, with each generation of displays more sophisticated than the last. The core appeal of fire and light will likely endure. Despite all the changes and innovations, the fundamental reason people love fireworks remains constant. Fire is primal, light is compelling, and explosions of color in the darkness create wonder. These are human constants, not dependent on technology or culture. As long as humans gather to celebrate, some form of spectacular fire and light will likely be part of those celebrations. The specific forms may change. Fireworks might become quieter, cleaner, more technologically sophisticated, but the core experience, the shared wonder of watching beauty bloom and fade in the sky above, will endure. Fireworks connect us to our past, to the ancestors who first mastered fire, and to our future, however we choose to paint the night sky with light in the centuries to come. The conclusion: And so we come to the end of our journey through the world of fireworks. We have explored their ancient origins in Chinese alchemy and watched them spread across the globe, becoming integral to celebrations in every culture. We have examined the chemistry that creates their colors, the physics that governs their flight, and the artistry that turns chemical reactions into spectacle. We have considered their impacts, both the joy they bring and the challenges they pose to environment and wildlife. We have seen how they have shaped history, marked important moments, and created memories that last lifetimes. Fireworks are more than entertainment. They are expressions of human creativity, demonstrations of our desire to mark important moments with beauty and grandeur. They connect us to each other through shared experience and to our past through centuries of tradition. They remind us that wonder is still possible, that the combination of science and art can create moments that stop us in our tracks and lift our eyes skyward. Each burst of a firework is ephemeral, existing for only seconds before fading into smoke and memory. Yet in those brief moments, something remarkable happens. Chemistry becomes light, force becomes pattern, danger becomes beauty, and a crowd of individuals becomes a community, united in their gasps and applause, sharing a moment that exists nowhere else and never again in quite the same way. As you lie here now, allowing your breath to slow and your body to relax, imagine yourself beneath a clear night sky. The first shell launches, trailing sparks as it climbs into the darkness. It reaches its peak and bursts, a chrysanthemum of gold spreading against the black. Then another, this one blue and silver, followed by a red peony that fills your vision. They come faster now, overlapping, colors mixing in the air. Greens and purples, whites and oranges, patterns spreading and falling in graceful arcs. Picture the smoke catching the light, drifting between you and the stars. Hear the echoes rolling across the distance, deep booms and sharp cracks mixing with the oohs and ahs of the crowd around you. Smell the distinctive scent of spent powder on the breeze. Feel the slight concussion in your chest when the largest salutes detonate. The display builds toward its climax. Shells fire rapidly now, dozens in the air at once. The sky becomes a solid canopy of light and color, overwhelming in its intensity. Sound becomes continuous thunder. Light fills your vision. Time seems to pause, this moment stretching, becoming everything. Then, suddenly, silence, darkness. The last sparks fade and fall. The night returns, deeper now after the brightness. The crowd stirs, speaking softly, beginning to gather their things. Above, the stars remain, patient witnesses to this brief human spectacle, as they have been for every fireworks display ever launched, as they will be for all those yet to come. If you are still awake, you can let these images fade now, allowing them to blend with your own memories of fireworks you have seen, celebrations you have shared. Or perhaps you are already drifting, the colors and sounds becoming part of your dreams. Either way, let yourself float on the gentle memory of beauty, of shared wonder, of light blooming in darkness. The night sky holds countless stars, each a distant sun burning in the void. But for a brief time, we add our own lights to that tapestry. We paint the darkness with human joy, marking time and celebrating existence with the most spectacular art we know how to create. Those bursts of color and light, those moments of shared amazement, connect us to something larger than ourselves, to the long human story of creating beauty and bringing light to the night. Rest now. Beneath that imagined sky or your own familiar ceiling, let the memory of fireworks, whether real or imagined, carry you into peaceful sleep. The colors fade to gentle darkness. The sounds diminish to silence. And all that remains is the warm comfort of rest, the letting go of wakefulness, the gentle slide into dreams where fireworks might bloom again in colors that have never been seen, in patterns impossible in waking life. Good night, sleep well, and may your dreams be filled with light and wonder. The end.